Welcome to Hartman Math. This is lesson 4.5, mixed quadratic graphs. Starting with example number 1, graph y equals x squared plus 2x plus 3. So this is in our standard form, y equals ax squared plus bx plus c. So we're going to identify the a, the b, and the c, and we're going to use the formula for axis of symmetry to find our middle x. So a is 1, b is 2, c is 3. So x is the opposite of b. So negative 2 divided by 2 times the a, which is 1x squared. And we get negative 1, that's our middle x. So then we can fill out the rest of the x's, smaller or left of negative 1 on the number line, negative 2, negative 3, bigger, 0, and 1. And then we can use calculator, we can evaluate by substituting in these values, such as negative 3 squared is positive 9, 2 times negative 3 is negative 6, so 9 minus 6 plus 3 is going to be 6, and then so forth, 3, 2, 3, and 6. So we can plot those points on a graph, draw the parabola. Domain would be all real numbers. We can substitute in any value of x. Range would be y is greater than or equal to negative 2. Vertex is right here, negative 1, 2. Y-intercept we can see there, 0, 3. Example number 2, y equals negative 2x times x minus 3. So this is in factored form. Negative 2 is your a times x minus 3. Factored form, also known as intercept form. So we can immediately find the x-intercepts. So this is the tricky one right here. Remember, the negative 2 is the a and it has nothing to do with the x-intercepts. X is the same thing as x minus 0. So we've got an x-intercept of 0, 0, and over here, think opposite, 3, 0. So we can plot those on the graph. Then our middle x is going to be halfway between 0 and 3. If we want to do it mathematically, add the 0 and the 3. You get 3 divided by 2 because you're averaging two numbers. And you get 3 halves or 1.5. Since there's a spot there and a spot there, that's why I left the room there so we can put 1 and 2. And those are the same distance away from our axis, so we will have symmetry. So we can now substitute those values into our function, like the 1, negative 2 times 1 is negative 2. 1 minus 3 is negative 2. Multiply those together, you get 4. And when you do the 1.5, you would get 4.5. So here are our points. Draw the parabola. It does open downward. It's a little narrower because of the a being negative 2. Domain, all real numbers. Range, y is less than or equal to 4.5. Y-intercept, 0, 0. Axis of symmetry, x equals 1.5. Example number 3, graph y equals a times x minus h squared plus k. So this one's in vertex form, the easiest in my opinion, because it's telling us the vertex. X coordinate, y coordinate. Think opposite inside the parentheses with x. 3, what you see is what you get, negative 4. Vertex, 3, negative 4. For our table, that's our middle x and y. We can immediately plot that point. So we've got 3, 2, 1, 4, 5. And substituting in values, like the 1 and the 5 should be the same because of our symmetry. 1 minus 3 is negative 2 squared is 4. Half of that is 2. Subtract 4 is negative 2 there and there. Might want to use calculator on the 2 and the 4. I think you're going to get a decimal there. Negative 3.5. Because of the a being a half, it's going to widen out our parabola. Draw it. Vertex 3 comma negative 4. Axis of symmetry, x equals 3. Domain, all real numbers. Range, y is greater than or equal to negative 4. We're not seeing the y-intercept. We can just substitute in a 0 to do it. So 0 minus 3 is negative 3 squared is 9. Half of 9, if we do it as a decimal, 4.5. 4.5 minus 4, 0.5. So 0 comma 0.5 is where it would hit here. A couple other things, just not necessarily needing to go all the way and graph these, but finding the intercepts. So we're talking about x and y intercepts, which we looked at in a previous lesson for the x-intercepts. So the y-intercept is the easiest one because all you got to do is substitute in 0 for the x's. X-intercept, we're going to set the whole thing equal to 0. Essentially, we're making f of x, which is the same as y, set that 0 because for all x-intercepts, the y-coordinate is 0. So set it equal to 0 and solve. We could try factoring. I don't think it's going to work with the 5x, with this being a negative 1 because there aren't very many options there. And I wouldn't do completing the square with this being odd. So I think we want to do the quadratic formula. A is 1, B is 5, C is negative 1. Let's do the quadratic formula. Opposite of B, plus or minus square root B squared minus 4 times A times C. So the A was 1. I didn't show that, so A is 1 times C. So we would get 25 plus 4 is 29. Negative 5 plus or minus root 29 over 2. I don't think we can simplify any of that. So for x-intercepts, parentheses, x, comma, the y is right there, so comma 0. We said the y-intercept would be pretty easy. Substitute in 0. 0 plus 0 minus 1 is negative 1. So we substitute in 0 for x. We got negative 1, which is our c value from standard form. So that's part A. Part B, this one is in intercept form. So the x-intercepts, since it's in intercept form, should be pretty easy. Remember, for our x-intercepts, something comma 0. So again, A doesn't matter for our intercepts, at least for the x-intercepts. Think opposite is one way to go. So 5 comma 0, negative 2 comma 0. Now for the y-intercept, that is going to matter because now we're substituting in 0, just calculating. So if we substitute in 0, so we're going to get 2 times negative 5 times positive 2 as the x's become 0. You make that calculation. Don't forget about the 2. You get negative 20. Example 5, part A, find the vertex. So we are back from standard form. Ax squared plus bx plus c. So just like we would do if we were graphing, we're going to use the x equals opposite of b divided by 2a formula. The opposite of b would be 3 divided by 2 times the a. So 3 divided by, well, positive times a negative is a negative. Half of 2 is 1, so we're talking about negative 1. Positive 3 divided by negative 1 is negative 3. That's the x-coordinate of the vertex. Now we need to substitute that in to find the y-coordinate. So substitute it in. Maybe use a calculator. You would get 6.5. Turn that into a point, x comma y, and we have our vertex. Example 5, part B, find the vertex again, this time from intercept form. So let's use that. We can't directly get to the vertex, but we can find the x-intercepts right away. 3 comma 0, negative 5 comma 0, thinking opposite. And not a detailed graph, but if we just do a quick sketch on that, what we're looking for is where would the axis go? Where's halfway between those? Or maybe you didn't even need the graph. You could just say, I'm going to add those together and divide by 2 to get the average. And that's going to be the middle x. I think we're going to find that at -1. So x equals -1. That's the x coordinate. When you want to know the y coordinate, just plug that into our function. So x is -1. Now do -1 here, -1 there. Multiply this out. We get -16. So our vertex is -1, -16. That's it for today. I'll see you next time.